Namaskar, my dear friends. Let us talk about how we can design and simulate Zener as voltage regulator in NI Multisim. So what we'll do is we'll design or we will create some circuits in NI Multisim like this, and we'll try to simulate and see what is the result that is going to come. Like how my Zener diode is going to clamp the output voltage to its knee voltage or its clamping voltage, that is 5.6 or 10 volt or 12 volt, whatever the voltage rating of the Zener diode, that it will be clipped off. Okay, so let us open let us open multisim, and I'm going to take a new design page. Okay, so this is the new page that is there. So let us start a circuit, general circuit from the scratch. So what do we do? Go to place, put a Zener diode. So I'm going to put a Zener diode of rating, let us say 6.2 volt. Okay, so for 6.2 volt I have the part number 1N 1N753. Okay, so this is the part that is there for 6.2 volt. So I'll write a comment here quickly so that you can always see this that my VZ is equal to 6.2 volt. Let me just make it blue. Okay, so this is Zener diode is done. Now what do we need to place? We need to place let us say sources. So I am going to put AC source at the input, and then we are going to have, or let us say we'll put DC source, not AC source, it will be little easy. And then we need to have a ground as well, so we'll just put one ground. And then we need to have resistors, so go to basics, resistors. I'll put one source resistor, as you know, and one more I'll put it as load resistor, and I'll delete this. That's all. Okay, so let us quickly wire it up and see how to regulate this particular voltage. Now I am going to change this resistor to, let us say, 3K. So 3K plus 1K, that is 4K. So here the voltage will come as 9 volt, which is more than VZ, and that's how it will be acting as a clamping voltage. So can we quickly wire this up? Wire it up. Now, like, you, for wiring up you don't have to do anything. Go to the tip of the component and it will start wiring up. Now let us put one probes. So this is my voltage probe at input, this is my voltage probe at output. What is the expectation that you are thinking? The expectation will be input voltage is 12 volt and output voltage should be, according to voltage division, it is 9 volt, but it will be regulated to 6.2. That's all. So this is how Zener simulation is done. See, it is 6.15 volt. Why I am telling you this is, just remove this and simulate it. What will be the voltage at this? 9 volt. Understood? Because of the R1 and R2 we have a voltage division, right? Now if I put the Zener diode, then what is going to happen? This 9 volt will be regulated to the knee voltage of Zener. So it will shift to 6 volt. If you want to see the graph, what you can do, before seeing the graph, what we'll do is, let us say I am going to change this voltage to let us say 4 volt. So what will happen? This 4 volt will be divided into 3 kilo ohm and 1 kilo ohm. So here it should be 3 volt, but this 3 volt should have been clamped by this Zener diode, but it is not able to switch on this Zener because of Zener is actually having 6 volt clamping voltage. Understood? So this will not switch on and the output will remain 3 volt. So let us say it is remaining 3 volt. Understood? Now if you want to plot the graph for the same, what you can do is go to simulate, analyze, and go to transient, let us say, and I will run it for, let us say, 1 microsecond, 1 millisecond. So you can see we have the output, we have the input voltage PR1. Okay, so PR1 is your input voltage and PR2 is your output voltage, which is going to be 3 volt. Okay, now now what I'll do is I will change the input voltage to, let us say, 12 volt. 12 volt. Then in that case my output should have been 9, but because of this Zener, it will limited to, it will get limited to how much? It will get limited to 6 volt. Okay, 6.2 volt. So let us see that. See, it is limited to 6.2 volt. Understood? Now, if you want to change this particular source to some, like AC source. So let us say put AC source components, let us say sources, signal sources, AC voltage. So this will go here, and we are going to connect this particular source. Now this is 6 volt Zener diode. So my aim is to make the input voltage, or the like input voltage is such that the peak voltage should be more than 6.2. So why don't we do one thing? Instead of this, I am going to make this one as 12 volt as we did, right? So 12 volt by 3, that is going to be here 9, right, it is 9 volt peak. So 9 volt will be limited to 6. It means at 9 it will be clipped to 6. So let us run it. So you can see only one cycle I have taken. So as soon as it goes more than 6.2, my input voltage, you can see the red signal is input and green is output. So as soon as it goes here, it gets clipped. That is, Zener comes into picture, and it starts regulating. And in negative direction, it is short circuited. So this resistor is not coming into picture. Just zero point 0.7 volt will be drop. Okay. If you want to run for more cycle, you can increase the simulation time. That is not a problem. You already know. You can see various like videos that we have put already, so you can do that. And if you want to find out what is the current flowing or all these things, you can put current probes or something like this and see what is the current flowing through the resistor. So the resistor current flowing through this will be actually it is very tough to see here. So what I'll do is I'll just remove this. Okay, remove all of them, and this one I can like increase this trace width, let's say 4. And if you want, you can have a cursor as well to see that what is the value. Okay, so let us say cursor. So this cursor, if you see, you are going to see what is the current that is there. uh, it should be y direction, right? So if it is y direction, so x1 y1 is -3 and y2 is 2. So it is 2 milliampere. Okay, so y2 is actually 2 milliampere. Understood? Maximum. That's all. If you want, you can calculate that as well, not a problem. Alright guys, thank you.